try to solve one numerical example using the Gauss-Jordan elimination method. So, in order to save the time here, already we write a system of a linear equation. Now we try to solve this system of a linear equation by the Gauss-Jordan elimination method. So, now how we find the solution of this system of a linear equation? Using Gauss-Jordan elimination method. As earlier we say that first of all we choose the pivot elements, means not a pivot element. Before choosing the pivot element, first we try to write this system of a linear equation into a matrix form. So, what is the equivalent matrix form of this system of a linear equation? Equivalent matrix form of system of a linear equation of given system of a linear equation, given system of linear equation is as follows, So, what is the matrix form? Means here we write the coefficient of x, y and z. So, this become what? This become 2, 4, minus 6, 1, 3, 1 and 2, minus 4, minus 2. This one is a value of a. Here we write unknown x, y and z. This one equal, here we write what? Here we write minus 8, 10 and minus 12. Minus 8, 10 and minus 12. Here we denote this matrix by the capital A, this matrix by the capital X and this one is a X. This means equivalent matrix form become AX equal B. AX equal B. Now we write a what? We write a augmented matrix. Now augmented matrix, here we write a augmented matrix, here we write like this one, means first we write the matrix A, partition, then matrix B. So, this one equal to, we write the coefficient matrix A. What is the coefficient matrix A? 2, 4, minus 6, 2, 4, minus 6, 2, 4, minus 6 and second row is a 1, 3, 1, 1, 3, 1, 1, 3, 1 and third row is a 2, minus 4, minus 2, 2, minus 4, minus 2 and partition. What is the values of B1, B2 and minus 8, 10, minus 12, minus 8, 10, 10 and minus 12, minus 8, 10, minus 12. So, once we verify 2, 1, 2, 2, 1, 2, 4, 3, minus 4, minus 6, 1, minus 2 and minus 8, 10, minus 12, minus 8, 10, minus 12. Now, after writing the augmented matrix, first we choose the pivot element and for the first stage of elimination, means elimination of a first variable except from the first equation, from all other equation, what is the pivot element? The common element of a first row and first column. So, here pivot element is a what? 2 and this one does not equal to 0. this one does not equal to 0. If this one equal to 0, then we perform the pivoting, means of partial pivoting or complete pivoting. So, here pivot element equal to and this one does not equal to 0. So, for the normalization, of a first row, pivot row is a what? Pivot row is a R1. First row is a pivot row. So, for normalization, we perform R1, we perform the row operation R1 tends to what? 1 by 2 R1, means we divide the first row by the pivot element. So, what is the equivalent matrix? Now, equivalent matrix become, if we divide the first row by the pivot elements, then this become 1 divided by 2, then this become 1, this become 2, this become minus 3 and this become minus 4, and there is no change in a second and third row. So, here 1, 3, 1, 10 and 2, minus 4, minus 2 and minus 12. This one is a partition. Now, we perform the elimination of a first variable from the second and third equation. So, for the elimination, we use the pivot row for the elimination of a 1 and 2, is the elimination of a coefficient of a x1 in a second row, second equation and from the third equation. For this one, we perform the operation on a R2 tends to R2 minus R1, 1 R1, 1 R1. R3 tends to R3 minus multiplied by 2, 2 R1, R1. So, this one is a stage of a what? This one is a elimination stage, elimination of first variable from second and third equation, second and third equation. So, after performing this operation, what is the equivalent form of a matrix? So, there is a no change in a first row, because first row is a pivot row 1, 2, minus 3 and minus 4. We perform the row operation on a R2 minus R1. So, this becomes 0, R2 minus R1, 3 minus 2, this one is a 1, 1 minus 3, this become 1 minus 3 minus minus become plus 4 and 10 minus 4, 10 minus minus 4, this become 14. And here R3 minus 2 R1, 2 minus 2, this one equal to 0, minus 4, this one is a minus 8 and this one is a minus 2 and minus 6, this one is a minus 4, minus 8 and this one is a R3 minus 2 R1. So, R3 with the minus 2 and minus 2 R1, minus 2 plus 6. So, this become 4. Once again we verify this one, minus 2 minus minus plus 3 2 is 6, minus 2 plus 6, this become 4. Now, next one is this one is a minus 8, means multiplied by minus 2, this become minus 8, minus minus plus 8, minus 12 plus 8, minus 12 plus 8, this become minus 4. Minus 4, what will happen? After first stage of elimination, means after eliminating the x1 from second and third equation, now we try to eliminate the x2 from first and third equation. For this one, again we choose the pivot element. So, here in a second stage, now pivot element pivot element here. Now pivot element is a what? Pivot element is a 1. Pivot element is already 1, so there is no need to perform the normalization, because in a normalization we try to convert the pivot element into a 1. So there is no need to perform the normalization. This one is already in a normalized form for the second variable, because the coefficient of a second variable is a 1. So here we perform the elimination, and this one does not equal to 0. This one already in a normalized form, already in normalized form. Normalized form. So there is no need to perform the operation R2 tends to 1 by pivot element R1, because there is no change, because if we try to perform the normalization, then this become R2 tends to 1 upon pivot element 1, this become R2. So this means there is no change in a R2 tends to R2. Now we perform the elimination. So for the elimination at this stage, what we will do here, which one is a pivot row? Pivot row is a what? Pivot row is a R2. Pivot row is a R2. So we perform the what? We perform the following operation for the elimination. So here we write a elimination stage. In the next step we write a elimination stage. For the elimination we perform the following operation, means once we write this matrix in the next stage, or after elimination we write this next matrix. So for elimination here, once we write a matrix again, equivalent matrix. Matrix is a 1, 2, minus 3, minus 4, 1, 2, 3, minus 4, 1, 2, 3, minus 4, 1, 2, minus 3, minus 4, 1, 2, minus 3, minus 4. Next one is a 0, 1, 4, 14, 0, 1, 4, 14, 0, 1, 4, 14, and next one is 0, minus 8, 4, minus 4, 0, minus 8, 4, and minus 4, 0, minus 8, 4, minus 4. Now we perform the elimination of a second variable, and pivot row is a second row. So we perform the R1 tends to what? R1 tends to R1 minus 2R2. Only we perform the multiplication and division in a pivot row. Here pivot row is R2. Pivot row is a R2. So R1 tends to R1 minus 2R2, and R3 tends to R3 minus and minus 8 R2, and this one is equivalent to what? This one equivalent to R3 plus 8 R2. So for elimination, now we perform this operation, now equivalent matrix. After performing this operation, so there is no change in a second row, because second row is a pivot row. So 0, 1, 4, 14. Now what will happen in a first row? R1 minus 2R2. This one is a 1, minus 2, 2 minus 2, 0. So this one is a minus 2 means this one is a minus 8, minus 3 minus 8, this one is a R1 means R1, minus 2 means minus 8 minus 3 minus 11, and this one is a minus 4 minus 2 R2 28, and this one is a R1 minus 2R2. 2R2 means this one is a 40 to the 28, 28 minus 28 minus 28 minus 32, minus 32. This one is a first row. Now, what will happen in a third row? This one becomes 0 and multiplied by here 8, 8 minus 8, this one is a 0, 8 4 is a 32, 4 minus 32, this one is a R3 plus 8. So, this one is a 8 4 is a 32 plus 4, this one is a 36, and this one is a, here we multiplied by 8, then this one become minus 4 plus 8 into 14. This become what? Minus 4 plus means 108. So, this one is a value what? 108. So, here we write this one is a 108, 108. So, this one is a, I think this one is a correct one. So, this one is a minus 11 436, minus 11 436, this one is a minus 32 14 108. Now, we perform the third stage of elimination. Third stage of elimination means we try to convert the third variable from the first and second equation equal to 0. The coefficient of a third variable x3 means from first and second equation equal to 0. So, for this one again we choose the pivot element. Now, pivot element for third stage of elimination, pivot element become what? 36. Now, this one become 36 and this one does not equal to 0. So, be able to apply the Gauss-Jordan method. Now, what is the pivot row? Pivot row become what? Pivot row become R3. So, for normalization, we perform what? R3 tends to 1 by 36 R3. So, after the normalization, what is the equivalent matrix? Equivalent matrix become, there is a no change in the first row, 1 0 minus 11, 1 0 minus 11, then this become what? Minus 32, and this one 0 1 4 14, and in a third row we multiplied by we divide by the 36. So, there is a no change in a first element, no change in a second element, and here we divide by the 36, then this become 1, and here if we divide by the 108 by 36, then this become 3. So, now we perform the elimination of a third variable from the first and second equation. For elimination of third variable, third stage elimination, if we write a third stage elimination. For elimination in third stage, or you may also write eliminating third variable, from first and second equation. Now, for this one we perform the row operation here. R1 tends to R1 minus plus 11 R3, 11 R3, and R2 tends to R2 minus 4 R3. Now after that, what is the equivalent matrix? Equivalent matrix become, this one become R1 plus 11 R3. Then this become what? 1 0 0, and 11 R3 means 33 minus 32. This become what? This become 1. Now this one become, if we perform the R2 minus 4 R3, means be multiplied by the 4 in R3 and subtract this one with the R2. Then this one is a 0, this one is a 1, this one is a 0, this one is a 4 3 is a, this one is a minus 12, 14 minus 12, this one is a 2, and last one is a what? Last one is a 0 0 1, and here there is a no change here, then this one is a 3. Now we stop this process. Why we stop this process? Because here we able to convert the matrix A into a diagonal matrix. This become a diagonal matrix. Diagonal matrix. Now if A become a diagonal matrix, then directly we able to write the value of a x is a 1, value of a y is a 2, value of a z equal 3. So rather than to write directly, here we write what? Here we write a equivalent system of a linear equation, or you may say reduced form of a system of a linear equation. So what is the reduced form of a system of a linear equation? So in the next phase we write what? This one is a reduced form of a system of a linear equation. Reduced form of a system of a linear equation. Form of system of a linear equation. System of linear equation. Linear equation. Now this become 1 0 0 0 1 0 0 0 1. Here we write what? X, y, z. This one equal 1 2 and 3. 1 2 and 3. Simply here we write a x y z. A, then x be the coefficient matrix, means of unknown. Not a coefficient matrix, means a matrix of unknown, x1, x2, x3, here x1 with the x, x2 with the y, and x3 with the z, means here unknown with the x, y, z. So here we write a x, y, z. So if we multiply this one, then we directly write a x equal 1, y equal 2, and z equal 3. This one is a what? This one is the answer. This one is the answer. This one is the answer. Answer. So this one is a what? This one is a solution of a any system of a linear equation having a unique solution with the help of a Gauss-Jordan method. So what is the summary? First of all, we write a given system of a linear equation as a matrix form of a system of a linear equation, then write the augmented matrix, then we choose the pivot element, and first pivot element is a common element of a first row and first column, or you may also say the coefficient of a x1 is a first pivot element and first row is a pivot row. Then we normalize the first row by dividing the first row by the pivot element. Once we normalize, then we perform the row operation to eliminate the coefficient of a x1, or we eliminate the variable x1 from the second and third equation, second, third onward equation, and we repeat this process for the normalization and elimination of a second variable, and similarly third variable, and if there is a n variable, then similarly for the n variable. Now once again I summarize, means what is the difference between Gauss elimination method and Gauss-Jordan method. In a Gauss elimination method, means what is the advantage and disadvantage of a Gauss elimination method over Gauss-Jordan method and Gauss-Jordan method over Gauss elimination method. In a Gauss-Jordan method, we only perform a one step, means a forward elimination, and convert the coefficient matrix A into a diagonal matrix. But in a Gauss elimination method, we find the solution in a two step. In the first step, we perform the forward elimination and try to convert the coefficient matrix into a upper triangular matrix, and in a back substitution we try to find out the solution. But in a Gauss-Jordan method there is a no any step of a back substitution, means of one step we reduced in a Gauss-Jordan method. But what is the drawback of a Gauss-Jordan method? The computational efforts that required in a Gauss-Jordan method is greater in comparison of a Gauss elimination method. That's why always any researcher or mathematician not prefer the Gauss-Jordan method, because computational effort is more in comparison of a Gauss elimination methods. Means there is a more number of a multiplication and division in a Gauss-Jordan method in comparison of a Gauss elimination method, means computational effort is a more in a Gauss-Jordan method. That's why the researcher and mathematician does not prefer the Gauss-Jordan method over Gauss elimination method. But what is the advantage? Advantage is that there is a no any back substitution step in a Gauss-Jordan method. So this one is all about this lecture. Thank you watching my lectures. Thank you.